Okay, if it helps you, you can kind of hear it one more time from me, just to see sort of these four types of problems. As I said, have a calculator handy. At least eventually you'll want to have a calculator handy. When you look at a problem like letter A, I hope that you notice that x is in the base. Why is that special? Well, honestly, if x is in the base, we don't want to use logarithms. I hope that you're just going to divide by 4. When you divide by 4, you're isolating, but you're getting yourself ready for the key step, which is to use reciprocals. So if you just need to hear this again, you do a reciprocal to both sides. When I say that, what I really mean is you do an exponent. You do an exponent.
You mean 5, not 50. You wrote 50.
I mean 5, not 50. Thank you. So we'll do an exponent of 3/2 to 5. Good. Thank you. All right. Now, make sure you can put that in your calculator correctly. You have to, for some calculators, you have to put parentheses around 3/2 as your fraction. Otherwise, the calculator is going to do an exponent of 3, and it's going to divide by 2. But we want to do an exponent of 3/2. So I'll let you put that in. It should be coming out to about 11.18. Of course, with one more decimal, it would be 11.180. So I don't know. Sometimes I'm using 2 or 3 decimals, but what's more important here is that you say, hold on here, Ms. Naylor. You said something about an even root yesterday. Yes, I did. If the denominator is even, that means it's an even root. And of course, that means plus or minus. So technically, there's 2 answers for this problem. That'd be the most important thing, that you get both of them. Notice that I'm looking at the denominator after I do the reciprocal. Now, letter B should catch your attention as x up in the exponent. And when x is up in the exponent, I know, look at it. It's all up there looking big and bad until you slap it with a log. When x is in the exponent, this is the power of logs. This is like one of the main ideas in this last part of this chapter. Because what happens? Exponents come tumbling down. And once the exponent comes tumbling down, now you got to kind of say, oh, it's like the entire 2x plus 1. Yes, the entire 2x plus 1. And now we're looking at a problem that, okay, it looks a little trickier. It's got more numbers, but they always kind of work out the same way. If you've done this a few times, you would realize that you always divide the log. So you should feel like on your calculator, you're always doing this division. Again, you divide the logs, I should say. Now, when you divide those logs, if you would like to get a little checkpoint, you get about 1.96. But are you comfortable keeping that number on your calculator, 1.96 ... and continuing to solve? You know, like subtracting 1 from both sides. I'm talking about the 2x plus 1, so I can subtract 1. Just keep that on your calculator, because now you should have a 2x equaling 0.96 ... And then you can divide by 2. So keeping all that stuff on your calculator and just kind of finishing the problem is recommended. There's no reason to round until you get to that last step. Okay, so very similar procedure. You always divide. When you take the log of both sides, you end up then dividing those logs. Now, letter C is a log equation. When you have a log equation, you're not going to use a log to undo it. But you do have to kind of use properties of logs, like condensing. When you see 2 logs, you have to say, okay, I need to condense this. Are we at the point that we can kind of do this in one step? Yes, you're going to get an x squared, but there's also a 5 that gets attached to that x squared. I would recommend you just write it all down in one step. Now, this base 3 that I circled in blue, that base is how you undo the log. You base both sides. It's called exponentiation. You base both sides with a 3. And over here on the right, it creates a power. It creates 3 to the 3rd power, which happens to be the number 27. Okay, it's a special kind of equation, so it requires special technique. You condense, and then you base. And then I hope on your calculator, you're just dividing by 5 and taking the square root of both sides. You can just do that on your calculator, divide by 5, and take the square root of both sides. Okay, now remember, you don't get plus or minus. You don't get plus or minus because you don't want to have a negative number for the log. So you can just leave the positive. Okay, and then letter D, honestly, it's of the same variety, but I just want to make sure that people aren't doing any bad habits. A bad habit here would be to say that you see a 6 and a minus and a 2, and somehow you do 6 minus 2 and you get 4. But it's not 6 minus 2. It's actually 6 divided by 2. So you want to see the subtraction sign, and instead you want to divide. Now, you don't need to show that step if you don't need to. Maybe you're like, yeah, that's just going to be 3. So if you would like to just skip right down to the log of 3, but again, you have to divide when you see subtraction. Now, I hope you're not worked up when there's a log on both sides. If there's a log on both sides, then the base is going to just cancel both of them. So I base both sides, but then both of them disappear. Well, that's convenient. That just leaves you with a nice little 3 equaling x minus 4. So it actually is a little easier because they both cancel. Now, those 4 problems are similar to the notes from yesterday, but now they're all scattered. They're kind of scattered around the paper, and I hope that you kind of work on each one at a time using the right technique. All the answers are on the back. Looks like they're just rounded to 2 decimal places, but not a big deal. I wanted, though, to give you the answers right away so you can right away check if all is well. If all is not well, then, let me give you a little help, or maybe talk to a friendly face.